बोलणार आहे all they are MCQs. So they are made up of mild steel. If you will cut this section, if you will cut this member at any point, you can see cross section of this metal member as it can be C section, it can be I section, it can be L section, or it is also known as angle section, or it can be T section. So any one of these is normally used as cross section for this member. Every single member of metal is known as strut, which is a slender member. What do you mean by slender member? When its length, that is longitudinal, is very much high as compared to its cross-sectional dimension. Means if I will cut this member, whatever cross-sectional shape it is having, whatever cross-sectional dimension it will have, it is very less as compared to its length. That's why the member is known as slender member. Is it clear?
मॅम ते होल स्ट्रक्चर ट्रसेस आहेत का?
हाँ, हे या प्रत्येक मेंबरला स्ट्रट म्हणतात. एव्हरी इंडिव्हिज्युअल मेंबर इज नोन ॲज स्ट्रट. ओके, एव्हरी स्ट्रट इज अ स्लेंडर मेंबर. Slender means whose length is very much high as compared to its cross-sectional dimension. Is it clear? Yes, this total structure is known as truss, which is made up of struts. Some struts are joined at the ends, and they will form a total structure of truss. Important concept or important, you can say, parameters related to these truss are, normally they are provided for industrial shades. They can be provided to cover some area. On these we provide our regular, ज्या काही आपल्या roofing sheets असतात त्या आपण याच्यावर टाकलेल्या असतात. This is metal structure which is supporting your roofing sheets. Always remember that whatever load is acting on this truss, it is acted on joints. No load is acting on the member. No load is acting on the strut. Strut वर कुठलाही load directly येत नाही. Whatever load is acting, external load will act only on joints. Is it clear?
Yes, ma'am.
Yes.
One support of truss is normally provided as hinge, and other is roller. Do you remember why roller is provided below bridge or so? I have told you.
Yes, ma'am.
Yes. काय होतं reason सांगा? त्यावर आपण एक सपोर्ट रोलर ठेवतो नेहमी मेटल स्ट्रक्चरला सपोर्ट करणारं.
एक्सपांड
Sag prevent करण्यासाठी.
तर क्रॅक प्रिव्हेंट करायला.
Prevent the sag.
Whatever loads will act on these joints, because of that all these members will have tendency to either have compression or tension in them, and to overcome these stresses which are developed in these members, we always keep one support as roller support, so that it will have its motion freely along that plane on which roller is resting, so that there will not be any generation of stresses, and ultimately your entire structure will remain in equilibrium. Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So our aim in analyzing these truss is, because of action of these external forces, we are going to find out what will be the internal stresses developed in these members. This is our aim of analysis. because we know that whatever internal stresses will be developed in the member and the externally applied forces along with these support reactions, entire truss will always be in equilibrium. Can you tell me what type of force system will be generated on this truss?
General.
Yes, general force system, because whatever external loads will be applied on the joints, whatever will be the support reactions provided by the supports, if you will extend their line of action, then obviously they will not meet or intersect at single point, nor you can say that they are parallel to each other. So they will form a general coplanar force system. Can you tell me what are the conditions for equilibrium of general coplanar force system?
Fx
Summation
0,
of
Fx
Fx
equal
and
to
Fy
0
0.
and moment 0.
Summation of them.
Yes, that third condition is very, very important when we
Momentum
talk
is also.
about, yes, when we talk about parallel or general force system, we must say these conditions should be fulfilled. That is, algebraic sum of moment of all the forces about any point in the plane must be equal to 0. So if these three conditions are satisfied with my entire truss, always remember our principle for analysis will be, if entire truss is in equilibrium, then every isolated smallest part of truss will also be in equilibrium. कळलं मी काय बोलली?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
so if I will isolate any member from its parent truss, if I will isolate any joint from this parent truss, every single member as well as every single joint will be in equilibrium as my parent truss is in equilibrium. Is it clear to all?
Yes, ma'am.
Okay, so this principle is very, very important. While analyzing, we are going to use it. Your analysis can be performed, can be done by using two methods. First is method of joints and second is method of section. Now one by one we are going to solve the problems for method of joint as well as method of section. दोन मधला basic difference सांगते, method of joints and method of section. Now because of action of external loads, analysis means we are going to find out what will be internal force created in these members. That is nothing but analysis. If it is asked to find out force in all the members of truss, then we will go for method of joints. It is for all members. And if specifically in the problem it is mentioned to find out force in this member, this member, this member or this member, likewise it is mentioned to find out force in that particular member giving its name, we will go for method of section. So particular member can be analyzed by using this section method. Is it clear? This method of joint is very simple, very easy. That way method of section is, I will say, difficult because it requires judgment. Next is method of joints is too lengthy. It is too lengthy, too tedious method. But method of section is very, that way it takes very less time consuming. Very less time it will require to solve the problem by method of section. But this can be asked as MCQ even, because now you are not going to solve subjective lengthy paper nahi hai, मतलब मोठा problem नसणार आहे. So these things can also be asked as MCQ, 1 mark MCQ. Is it clear?
Yes, ma'am.
Chalu
Yes,
pude?
ma'am.
Yes.
Yes, ma'am.
Now I will come back to our parent truss. I will first erase all the loads which I have shown. Before starting our problem, it is expected that we need to check for determinacy for the truss. Determinacy means nothing but whether the truss is perfect truss or not. Is it feasible to find out all the unknowns by using our conditions of equilibrium or not? That we need to check. So for that, first I will number all these members. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. How many members are there?
13.
13.
13 members.
Now I will number joints. 1, 2, 3, 4, 5, 6, 7 and 8. How many joints are there? 8.
8.
Okay. This is hinge support. How many reaction components hinge can provide?
2.
It restricts horizontal motion, it restricts vertical motion. So 1 and 2, HA and VA. And what about this roller? Roller will provide how many reaction components?
Only one.
It
Single
will be
one.
perpendicular to the plane on which roller is resting. Roller is resting on horizontal plane, so vertical will be support reaction. So 1, 2 and 3. Support reactions are 3. इथपर्यंत सगळ्यांना समजलं?
Yes, ma'am.
Okay, so there is one equation to check whether the truss is perfect or imperfect truss. It is your equation of M equals to 2J minus R, where R depends on type of support. These two you can easily calculate just by looking at your truss. Members are 13, joints are 8, and here in this case reactions are 3. Reaction components are 3. So 13 is getting balanced by right hand side 13. Is it clear?
Yes, ma'am.
If this equation is satisfied, it is known as perfect truss, or you can say determinate structure. Is it clear to all? This is very important MCQ. Truss. What is perfect truss? What equation should be satisfied? M equals to 2J minus R. What M stands for? Number of members. What J stands for? Number of joints. What R stands for? Number of reaction components. Is it clear?
Yes, ma'am.
सगळ्यांना
Yes, ma'am.
समजलं? चलू पुढे.
Yes, ma'am.
Yes, ma'am.
Now remember that it can be a case that in my truss, M, whatever I have provided, number of members can be more than 2J minus R. This can be a case. Sometimes some additional member is suppose provided in the truss, which is not actually required to keep the truss as perfect truss. It is giving one more member, additional member. 1 or 2 माहिती नाही, but minimum 1. So what we can say, such type of truss is known as redundant. हे ओरल मध्ये विचारणार आहे हा. Redundant truss. Important MCQ. If your M is less than 2J minus R, then I can call that truss as deficient truss. Deficiency आहे त्याच्यात मेंबरची. Is it clear?
मॅम ते मिनिंग सांगता का एकदा? रिडंडंट आणि
Yes
डिपेंडंट.
बेटा. Redundant आणि आता इथे आपण काय केलंय? This is my perfect truss. बरोबर? जिथे इक्वेशन सॅटिस्फाय झालं M equals to 2J minus R. Yes or no?
येस मॅम.
Yes. If I will increase one more member, suppose from this joint to this joint, I have taken one more member in the truss. Now if I will write down my equation m equals to 2j minus r, whether my left hand side is equals to right hand side? No.
No, ma'am.
Correct. What is happening? Left hand side is increasing by 1.
Yes, ma'am.
Barabar?
Increase.
So I can say that m is now more than my requirement of 2j minus r. So such type of truss where additional member is provided, which is not actually required to keep the truss as perfect truss, it is known as redundant truss. Okay, समजलं?
Yes, ma'am.
Opposite can be a case. If I will remove any one of the member, हा मी member 4 नंबरचा member remove केला truss मधनं, whether my equation m equals to 2j minus r will get satisfied?
No, ma'am.
No, ma'am.
Joints are remaining same, reactions are remaining same, but one member will be less. So 12 cannot be equal to 13. Correct? It will be deficient truss.
Yes, ma'am.
I require one more member to make it perfect truss. बरोबर ना?
Yes, ma'am.
Yes. So this is that condition. This is standard condition. In your syllabus, you are going to solve all your trusses by this way only. These are applicable for second year and third year students of civil branch. Here they will study regarding redundant and deficient truss. Is it clear? But these are important MCQs for first year students. म्हणून मी स्टार मार्क करून दिलाय. प्रॉब्लेम कसं येईल MCQs ते पण सांगते. It can be given that a truss is having these many members, these many joints, and it is supported by one hinge and one roller. The truss is, options are redundant truss, deficient truss, perfect truss, imperfect truss. काही पण विचारते. Is it clear?
Yes, ma'am.
Yes,
You
ma'am.
need to apply this equation. You check what relation you are getting for left hand and right hand side, and you can comment whether it is redundant, perfect or deficient truss. I hope सगळ्यांना समजलं असेल. चलू पुढे.
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am,
Yes बेटा.
ma'am, I was not able to hear, ma'am. What are M, J, and R, ma'am?
M is number of members, जे मी इथे काउंट केले. J are number of joints, जे मी इथे ब्ल्यू रंगाने दाखवले. And R are number of support reactions, reaction components. So this is your standard equation. M equals to 2J minus R. Done? समझलं?
मैम
Yes बेटा.
मैम डेफिशिएंट ट्रस में 1 से ज़्यादा भी कम हो सकते हैं ना मेंबर्स?
कितने भी कम हो सकते हैं, बस इतना ध्यान में रखो कि ये इक्वेशन में लेफ्ट हैंड साइड लेस है एज कंपेयर टू राइट हैंड साइड, तो डिफिशिएंट. यहाँ पे अगर ज्यादा है तो इट इज रिडंडेंट.
ओके मैम.
दैट नंबर डजंट काउंट कि 1 है, 2 है, 3 है. नो. ओके, सिर्फ ये सेटिस्फाई नहीं हो रहा है, इक्वल नहीं है, दैट्स इट.
ओके मैम.
ओके, सगळ्यांना समजलं? चलू पुढे. चलू पुढे.
Yes, ma'am.
Yes,
ma'am.
Now while analyzing the structure using any one method, that is method of joint or section, some basic things must be known to you. What are our assumptions for analysis? So I am going to read it for you. मी हे तुम्हाला नंतर सेंड करणारच आहे. One by one I will read. First is all the members of truss are straight and connected to each other at their ends by frictionless pins. Important MCQ लक्षात ठेवायचं. मी हे पाठवणार आहे तुम्हाला, डोंट वरी. ओके, हे मी अपलोड करेल क्लासरूमला. So always remember that your truss are connected only at joints. They are connected at the ends which are forming joints, and all these joints are frictionless pins. ठीक आहे. आपल्या सीझर मध्ये जी इंटरनल पिन असते ना, इंटरनल हिंज वाली, तशी पिन आहे इथे सगळीकडे.
Yes, ma'am.
कळतंय सगळ्यांना? ओके, चलू पुढे. तुम्ही बराबर रिस्पॉन्स करा तर आपण पुढे गाडी लवकर
Ideal असेल
सरकू.
ना, आयडियल असेल ना फ्रिक्शनलेस म्हणजे.
काय असेल?
आयडियल म्हणजे.
हा, आयडियल पण म्हणजे त्याने तुम्हाला काही घेणं देणं नाही. ऍज तुमच्या याच्यामध्ये त्याचा काही रोलच येत नाही. ते पुढचे जेव्हा सेकंड इयर थर्ड इयरचे अनालिसिस असतात ना तिथे ते लागतं. आता तुम्हाला फक्त हे एमसीक्यू साठी लक्षात ठेवा की स्ट्रक्चर कसं असतं ते. एंडला कनेक्टेड असतं, फ्रिक्शनलेस पिन्स असतात. समजलं का सगळ्यांना?
Yes, ma'am. Yes.
Yes, ma'am.
नेक्स्ट, all loadings that is external forces जसे मी पहिल्या फिगर मध्ये काढून दाखवले होते. ऑन ट्रस आर ऍक्टिंग ओनली ऍट द जॉईंट्स. फक्त सगळे पिनवर म्हणजे त्या जॉईंटवर ऍक्ट होतात एक्सटर्नल लोड्स. नो लोड विल बी देअर ऑन मेंबरवर डायरेक्टली कुठलंही लोड ऍक्ट होत नाही. द मेंबर्स आर assumed to be weightless. It means that we are going to neglect self weight of the member. मेंबरला आपण एंटायर ट्रसवर ऍक्ट होणारे जे काय एक्सटर्नल फोर्सेस आहेत, वॉट एव्हर एक्सटर्नल लोड्स आर ऍक्टिंग ऑन द एंटायर ट्रस, दे आर very much high as compared to self weight of all strut or members. Because of that we neglect self weight of strut. Is it clear?
Yes,
Is
ma'am.
it clear?
Yes, ma'am. Yes, ma'am.
Next, all the members of truss and external forces acting at pins lies in the same plane. That's why they are forming coplanar force system. We call it as general coplanar force system. Okay.
Yes, ma'am.
Yes, ma'am.
Next is static equilibrium conditions are applicable for analysis of perfect truss. हे मी तुम्हाला सगळ्यात पहिलेच सांगितलं की ऍज वी आर कन्सिडरिंग इक्विलिब्रियम ऑफ जनरल कोप्लेनर फोर्स सिस्टीम, इक्वेशन्स ऑफ इक्विलिब्रियम और कंडिशन्स ऑफ इक्विलिब्रियम आर summation fx is 0, fy is 0 and m is 0. That is algebraic sum of moment about a point in the plane for all the forces is equal to 0. Now this sign convention is very important. I will come back to journal. Now if suppose आता एकदम म्हणजे एकदम मन लावून लक्ष द्या आणि नीट ऐका. हे मी परत रिपीट करणार नाही. And this is very very important concept for you can say entire truss as well as entire unit number 2. If suppose there is some member AB, obviously the axis passing through it is known as longitudinal axis. यातनं पास होणाऱ्या axis ला म्हणतात longitudinal axis. So through this longitudinal axis, suppose there is action of two equal and opposite pulling forces which are of magnitude f. Can you tell me what will happen to this member AB?
Steady, ma'am. It will not move.
स्टेडी.
Will it be steady or whether there will be some tensile force developed in the member AB?
Tensile force, ma'am. Tensile force.
As from both the ends, yes. As from both the ends, I am applying some pulling force to the member. Obviously, this member will try to expand in both the directions. It will,
Yes, ma'am. Yes.
it will experience some tension. But now if I want to keep my member AB in equilibrium, I don't want this end A or B to get expanded. Obviously, if I will draw free body diagram for joint A, to keep joint A in equilibrium, to balance this external force F, what type of force should be generated in the member?
Tension.
Can I say that such type of force is required to balance this external force F so that member joint A will be in equilibrium? Yes or no?
Yes, ma'am. Yes.
Yes,
Yes,
ma'am.
ma'am.
Whether it will be a condition at joint B, external pulling force is there. So internal same amount of pulling force should be applied to joint B inside the member to keep joint B in equilibrium. Yes or no?
Yes, ma'am.
Yes, ma'am.
This is nothing but your external applied force is getting balanced by internally applied tensile force at joint A. Same way internally applied or internal resistance force, that is your opposite directional member force, will be responsible to balance this force F so that your joint A as well as B will remain in equilibrium. This is the way we show tension or pulling force externally असू द्या, internally असू द्या member मध्ये. But this we show when we show it applied on a joint. So tension is always shown by arrow going away from the joint. Is it clear now? Is it
Yes,
clear
ma'am.
now?
Yes, ma'am.
Yes, ma'am.
But at the same time, if I will talk about member AB, see in member AB, to balance this force F, obviously there should be internal force like this. To balance this pulling force, there must be internal force at B like this. Yes or no?
Yes, ma'am.
So when
Yes,
we
ma'am.
talk about a member, tension is shown by arrow towards each other. This is regarding member. आपण आतापर्यंत जॉइंटच बघत आलोय. On joint, your pulling force or tension can be shown by arrow going away from the joint. But in case of member, your tension can be shown as arrow towards each other to balance this externally applied pulling force. Is it clear to all?
Yes, ma'am.
कारण आपल्या खूपदा असा समज असतो, आपल्याला असं वाटतं की टुवर्ड्स येणारे ॲरो म्हणजे कॉम्प्रेशन, म्हणजे ते आतमध्ये पुश करतात. नो, they are trying to pull your joint A inside so that it will remain in equilibrium. They are trying to pull your joint B inside so that it will balance externally applied pulling force and it will try to keep B at its original position. Is it clear? समजतंय सगळ्यांना?
Yes,
Done?
ma'am.
समजलं?
Yes,
So this
ma'am.
is,
Yes, ma'am.
by this way you will show tension in member. Now same way, if suppose there is some member which is now acted upon by some pushing force from both the ends, which is longitudinal axis वर act होणार आहे. Can you tell me what will happen to this member AB in this case?
Compression.
Compress.
Obviously it will try to get compressed, and to balance that, if I will draw free body diagram of A, my external F must be balanced by internal force.
Yes,
At
ma'am.
B, also my external pushing force must be getting balanced by internally pushing force towards this point B. बरोबर का?
Yes,
Yes,
ma'am.
ma'am.
So inside the member, when I want to say that my external F should be balanced by internal force, obviously to balance this rightward or this directional force, there must be force like this applied at joint A. Yes or no?
Yes, ma'am.
Same way, for this pushing force, there must be some balancing force like this inside the member to make this nullify or to make it nullify and to keep the joint B in equilibrium. See the arrows. Arrows are going away from each other. This shows that there is compression in the member. एकदा या दोन कन्सेप्ट जर क्लिअर झाल्या तर मग पुढे it will be very easy for you to Draw that properly on your parent truss whether the member is in tension or compression. समजलं काय सगळ्यांना सांगा मला पटकन.
Yes, ma'am.
Is it clear to all?
Yes, ma'am. Yes.
Yes.
ही डायग्राम किंवा हा स्क्रीनशॉट घेऊन ठेवा. दिस इज व्हेरी इम्पॉर्टंट. हा तुम्हाला पुढेही लागतो. एक्झॅक्टली अपोजिट असतं मेंबर आणि जॉईंट्सवर. When we say that there is some member which is resting at joint A, it is in tension. I will show it like this, arrow going away from the joint. But when I want to say that member AB is in tension, I need to show that tension by arrows towards each other. घूर के देख रहा है. When I say that A is having some pushing force or compressive force acting on it, but when I say that this is my member which is experiencing compression, it should be arrows going away from each other. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
राहिला तर लक्षात आहे. चलू पुढे.
Yes, ma'am.
Yes, ma'am.
We will solve directly a problem which will obviously be helpful to clear your concern. First method is dividing. First is method of joints.
And can you repeat?
Yes, beta. Just nothing I have told. Just method of joints likho. Under that we will solve this problem. Can you draw this figure? Find forces in all the members. केली सगळ्यांनी फिगर ड्रॉ? Yes.
1 minute, ma'am.
Okay. All the angles are 60 degrees.
Ma'am, the 31.5, na?
Yes, beta. 31.5 downward. चलो पुढे.
Yes, ma'am.
Yes. First step. Apply conditions of equilibrium to entire truss. As our entire truss is representing general coplanar force system, I will apply one by one all the conditions of equilibrium. Before that, I need to complete my free body diagram. These 18 kilonewton, 27 kilonewton and 31.5 kilonewton are acting on joints C, D and E respectively. At A there is hinge. Can you tell me how many reaction components will be there for hinge?
2.
One horizontal, one vertical. So I will name this as HA and VA. At B there is roller which will give one support reaction. So I will draw it as RB. Now I will apply one by one all my conditions of equilibrium. first condition of equilibrium summation fx is equal to 0 as there is no external force applied in x direction. My internal support reaction will be directly 0. HA. Barobar?
Yes, ma'am.
Yes, ma'am.
I will go for second equation, summation Fy is equal to 0. This will give me VA upward plus RB upward will be equals to all these downward forces I will take with plus sign on right hand side. So it will be 18 plus 27 plus 31.5. Barobar ka?
Yes, ma'am.
Can you tell me what sum you are getting?
76.5.
Kiti?
76.5.
76.5.
76.5. Okay. My third condition of equilibrium is algebraic sum of movement of all the forces about
Point A.
A.
hinge. म्हणताना hinge म्हणायचं so that it will have HA and VA movement 0. That's why we are taking movement about hinge so that directly we will be able to find out reaction at roller. बरोबर का?
Yes, ma'am.
So
Yes,
can I
ma'am.
say that this must be equal to 0? I will start with point A. HA and VA will create 0 movement. Next is downward force 18 kilonewton. If I will extend its line of action, it will lie somewhere here with downward direction. So it will create clockwise rotational effect about point A. It will be 18 multiplied by, as this is angle 60, 60, 60, it is equilateral triangle. So half of the distance will be 2.4 होता इथे. So it will be 2.4 by 2, that is 1.2. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Next is your 31.5 kilonewton force, again downward about point A, it will create clockwise rotational effect. So I will again write it with plus sign, that is 31.5. Now movement arm is 2.4. So into 2.4. Next force is 27 kilonewton. Again I will take its line of action over here. Downward force about point A, it will again create clockwise rotational effect. So with plus sign I can say it is 27 into, now the distance is 2.4 plus 1.2. So it will be
3.6.
3.6 meters from point A. And lastly my RB is upward. So about point A it will create anti-clockwise rotational effect. So write with minus sign, it will be RB into 2.4, 2.4, that is 4.8 is equal to 0. Is it clear to all? Equation सगळ्यांना समजलं?
Yes, ma'am.
Yes, ma'am.
Yes.
ma'am.
Tell me, what value of RB you are getting? क्या आलं बेटा?
40.5.
40.5.
40.5.
Put this value in this first equation, that is VA plus RB is equal to 76.5. So that you will get value of VA will be equals to 36.
36.
बरोबर?
Yes, ma'am.
Yes, ma'am.
HA is 0, VA is 36 and RB is 40.5. Is it clear? इथपर्यंत सगळ्यांना समजलं असेल, मला वाटत नाही काही डाऊट असेल. Okay, this is my first step. Now second step, this is very lengthy problem, it takes lot of time. Now it is asked to find out forces in all the members. Now second step is, just write down theory लिया थोडीशी. Isolate one by one, isolate one by one all the joints of truss, all the joints of truss so that the joint must not have more than two unknown two unknown members meeting at it.
Ma'am, two unknown member.
Meeting, MEETING, meeting at it. It's a simple words मध्ये आता meaning सांगते. You need to select that joint. आता तुम्हाला one by one you have to isolate all the joints from parent truss. Our basic principle आधीच सांगितलं मी. If entire truss is in equilibrium, every isolated member or joint will also be in equilibrium. So now what I will do? I will select a joint which is not having intersection of more than two members. If I will isolate joint A, you can see that at joint A, now I know value of HA, now I know value of VA, and there will be some force in member AC and force in member AE. So how many unknowns are there? If I will isolate joint A,
Two unknowns.
2
1 and 2, बरोबर का?
Yes.
If I will isolate joint C, can you tell me this downward force is known to me, which is 18 kilonewton, but along with that, force in member AC, force in member CE, and force in member CD is unknown. So how many unknowns are there?
3 unknowns.
3 unknowns.
3.
If I will isolate joint E, how many unknowns are there? 1, 2, 3, and 4.
4
4 unknowns.
If I will isolate joint D, 1, 2, and 3. 3 unknowns are there. Again, if I will isolate joint B, RB is known, 2 unknowns are there. So I can start my problem with the joint which is not having more than 2 unknowns. काय असेल रे कारण याच्या मागचं? Can you tell me what should be the reason?
Summation FX and FY काढता यायला पाहिजे ना.
Exactly, because we know that when we isolate a joint, if suppose this is joint A, this is suppose HA, this is VA. HA is already 0, so even if you will not draw it, it will be okay. Don't draw it. This will be VA. There is one force in this way, one force in this way. So there will only be 2 unknowns, and you know that at this point there is concurrent coplanar force system which is generated at point A, which is A's point of concurrency. So here if I say that A is in equilibrium, only 2 conditions of equilibrium I am having, summation Fx is 0 and summation Fy is 0. Using 2 conditions of equilibrium, I will be able to solve at the max 2 unknowns. Yes or no?
Yes, ma'am.
Barabar? That's why I will take such joint which is not having more than 2 unknown members meeting at it. If I will draw B, then it will be RB. One member is like this and one member is inclined. Now the condition number 3. हे तर आपल्याला पाळायचं आहेच. Along with that, what is our assumption? Initially assume that your unknown members are carrying tensile force. Tension is shown by arrow going away from the joint. बरोबर का?
Yes, ma'am.
So this is force in member AC. This is force in member AE. This is joint B. So it is force in member EB or BE. This is force in member BD. Is it clear to all?
Yes, ma'am.
सगळ्यांना समजले?
Yes, ma'am.
Now it is entirely your choice. ज्याला जॉईंट ए सॉल्व्ह करायचा असेल त्यांनी ए सॉल्व्ह करा, ज्याला जॉईंट बी सॉल्व्ह करायचा असेल त्यांनी बी सॉल्व्ह करा. द ओनली थिंग इज दॅट हे मी आता इथे आपण आज इथेच थांबणार आहे. हे दोन्ही जॉईंट तुम्ही सॉल्व्ह करून मला नेक्स्ट टर्नला हे जे काय अननोन 4 फोर्सेस आहे हे सांगणार आहे. या पॉइंट येस बेटा.
मैम इससे रिलेटेड नहीं है मैम, आपने जो असाइनमेंट दिया था उसमें तो क्वेश्चन थे मैम.
नहीं, इसका और इसका कोई रिलेशन नहीं. इट वॉज फॉर यूनिट नंबर 1.
मैम एक डाउट था उसके लिए, पूछ सकता हूँ मैं अभी?
अभी मत पूछो, अभी मैं अटेंडेंस लेती हूँ, बाकी लोगों को फ्री करती हूँ. आपका ब्रेक पीरियड ब्रेक टाइम है, आप मुझे पर्सनली व्हाट्सएप पे भेजो जो भी डाउट है.
मॅम आणि ह्याच्यात जे इन्क्लाइंड आहेत ना
Yes,
त्यांना रिझॉल्व करावं लागेल ना.
येस बेटा. आता इथे तुम्ही कॉन्करंट कोप्लेनर फोर्स सिस्टीम जनरेट होते आहे म्हटल्यावर यू कॅन गो बाय समेशन एफ एक्स इज 0 एफ वाय इज 0. काय आन्सर येतं बघा. प्लस आलं तर तुमचं ऍझम्पशन ऑफ नेचर ऑफ फोर्स इज करेक्ट. जर प्लस आन्सर आलं म्हणजे आपण म्हणू की हो खरंच एई किंवा एसी ह्या टेन्शन मध्ये आहे. पण जर माझा आन्सर मायनस आला तर मी काय कमेंट करीन, इट इज नॉट इन टेन्शन, इट इज इन कॉम्प्रेशन. तो मी त्याला जेव्हा नेक्स्ट मेंबरवर किंवा नेक्स्ट जॉईंटवर ड्रॉ करेल तेव्हा मी त्याला कॉम्प्रेसिव्ह फोर्स म्हणून ड्रॉ करेल. हेच मला तुम्हाला शिकवायचं आहे. बट वी विल स्टॉप टुडे ॲट दी स्टेज ओनली, कारण मग मला अजून 10 मिनिट पण कमी पडतील आपल्याला प्रॉब्लेम कम्प्लीट करायला. सो एवढं मात्र सॉल्व्ह करू शकता असं मी एक्सपेक्ट करू शकते का तुमच्याकडून.
Yes, ma'am. Yes.
Yes, ma'am.
जॉईंट ए
Yes,
आणि
ma'am.
जॉईंट
ma'am.
take
Yes,
this
ma'am.
as homework, okay, and try to complete this. In tomorrow's lecture we will continue from this step only, okay.
Thank you, ma'am.
Yes, wait बेटा, attendance व्हायची आहे. थँक्यू नका म्हणू लगेच. बस होतच आहे 5 मिनिट. हो. अटेंडन्स रोल नंबर 1 2 दिसत नाहीये मला. अब्सेंट आहे का.
Yes, ma'am.
So roll number 2 is absent. Fine. Next is 3, 4,
Present, ma'am.
5, 6. 6 पण दिसत नाहीये. 7, 8.
Present, ma'am.
कनक. Yes. 9, 10.
Present, ma'am.
Present, ma'am.
11, 12.
Present, ma'am.
मैम